let's say this is your image, RGB image. Let's say I call this is R, G, and B. Alright? So the size of the matrix is basically 7 times 7. So this is what we have. They're including the padding. Okay. So the image size is width is high, width is 5, 1 in the purple one. Okay. The purple one, 1, 2, 3, 4, 5. So this is the width, this is the height. 1, 2, 3, 4, 5. What is the D? They have three square of D in purple color. 1, 2, 3. So that means later on in Keras or TensorFlow, we're going to use 3 for RGB image. So be careful. Let's say we convert into gray image, it's become D equal to 1. So in TensorFlow later on, you need to decide D equal to 1 for the channel size. Alright, so let's have a look. Okay, what it means by number of filters. This is the number of filters. I have 2 filters. 1, 2 filters. Each of course need to map with the 3D, right? 1, 2, 3, 1, 2, 3. Okay, 1, 2, 3. So let's try like that. I think we can do some hands-on. We can calculate to get 11 here. Then we have the receptor field size. Okay, receptor field size, the one in red. Okay, the size again is 1, 2, 3. What width, height, 1, 2, 3. Dimension again is must map with the previous layer, because you can assume this is the first layer. Okay, so if you have later on higher than this one, it must follow the previous number of dimensions. Okay. So padding is the one in green. So if you see here, I have P equal to 1 because I just add 1 extra 0 to the next. Okay. Stripe. Okay, what it means by stripe? Okay, stripe means how they move as a windows. See, they move by 2 pixels, right? 2, 2. Okay, this is mean by stripe because at least we have the fundamental on understanding CNN. Later on, you need to do your calculations. I appreciate you do your own calculation and see how you calculate number of neurons. For example, like those who are from ANN, very straightforward. You calculate number of neurons. For example, like Jacob mentioned yesterday, how you define your neurons. It's up to you. But in order for you to design your network, you need to know what is the before layer, the previous layer, to be connected to the next layer. Because you need to understand the architecture. Only that you can define what is the best, the value to be defined. Because you need to calculate the neurons. Neuron and also the number of weight connected to each neuron. Alright, so you want to try 11, how to get 11, at least you get more feel on this one. So very simple. So we just multiply, okay, I think if I go back to the earliest one. So you can imagine, very simple. So in order to get 11 here, okay, so this is belong to the first filter here, right? So this green, the answer from this first filter, because I said my filter have k equal to 2. So end up I have only 2 as the output. The dimension here, 2. So here, this is refer only to this green bulb. So very simple, 0 times 1, 0 times 1, 0 times 1, 0 times 1. So only this value basically you multiply. 2 times 1, which is 2. 2 times 1, which is 2. So that means you have 2. Yesterday, very simple like the same thing, except now they are spatial connected. Yesterday, all neurons are connected to one to make it one perceptron. Remember, right? So now only this, which one to be connected to be calculated. Okay, so now I have, let's say this first dimension. So I have a 2 only. Okay, let's move to the second one. So again, I check 2 times 1 is 1, right? 2 times 1 is 1. I have 2. Next, I have only here, the rest are 0, we don't care. So 2 times 1 is 2, right? 2 times 1 is, sorry, I'm wrong. 2 times, 2 times 0 is 0. 2 times 1 is 2. 2 times 1 is 2. So it's 4, right?
Even up there was 4, right? First one was 4, right?
Oh, first one is also 4?
Yeah,
Okay, sorry. Okay, you are right. My fault. So when you add up, you're supposed to get 11. And that looks So now we have all ones here. Only 3, right? This is how massive computation in CNN. So you can imagine, like human, we do maybe 30 seconds, for example, just now, it's a group of people. Now every course are calculating this one, that's all. It's very, very fast now. So this is the basic of CNN. Compared to ANN yesterday, we call this a spatial connected. Not all, only the receptive field. The receptive field that match to our image have this one. Okay, so